All right, we're going to learn about lines of best fit because in the real world, things don't make like normally a perfect line. Okay, so scatter plot shows the relationship between two variables. Okay, so you're going to have graphs. There's different types of relationships. There's a positive relationship. So that means that I'm going to have a bunch of data points that don't quite make a line, but I could draw a line through them. And when I draw that line through them, it's going up. So they call this a positive correlation. Okay, same thing happens with a negative correlation. It's a bunch of dots going down. It's like when you gas your car up. Your car doesn't get the same amount of miles per gallon every single time. It fluctuates, but it stays close. Like you can make a good estimation. Okay, and then finally, when something has no correlation, that just means like the dots are everywhere. There's nothing that you can, nothing that you can assume from that. Okay, so the line of best fit is basically a prediction. And so it goes through we're going to put this in parentheses because it's not really called the middle, but that's why they call it best fit of the data. Okay, so for example, on this first example here, it says the data below shows resting heart rates of women ages between 20 people at the gym, which represents the data the best. Okay, and so if I do this first one, I'm going to draw line A. Line A starts at 80, and the slope is down 2 over 3. Down 2 over 3. Down 2 over 3. Down 2 over 3. So if I draw this line in there, okay, it looks like that. Okay, I don't think that follows the data very well. That's not the best line. Okay, if I go to this one, it goes through at 75, and it's going down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. So if I draw this line, it goes like that. To me, red is better than blue. So I'm going to cross off blue. Okay, red is definitely better than blue. Maybe there's one that's better. Okay, then if I do 80, down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. Okay, to me, it looks like, that orange one is like above the data. So that's not, I still think red is better. Okay, and then the last one is 50. Y equals 50, so the slope is 0. So it's just this line like this, which doesn't even go through the data at all. So it really has to be this red one. That has to be the best. Okay, so it's just an estimation. It's not something that is exact. Okay, and so you're going to learn on the calculator, it will give you an exact one, and we're going to learn how to do it on the calculator, but only when we're together. So I'm going to make this video assuming that we haven't learned how to do it on the calculator. Okay, so if I look at this next example, determine which one is the best. So first off, I know it's not A because that goes through at a -2 and it's a positive slope, up 3 over, it's going this way. That's not even going, I'm getting that one out of there. It's definitely not C either because that's also a positive slope, and this thing is definitely going downhill. So I know it has to be B or D. So if I do B, it goes through at a -2, and then I'm counting up 1, 2, 3 over 1, 2, 3, 4, 5, or down 3, forward 1, 2, 3, 4, 5. To me, when I sketch that line, it doesn't really look like it goes through the data. To me, I don't think that's a very good line. But if I do the other one, if I do this one, start at a -2, up 1, 2, 3, 4, 5 over 3, or down 1, 2, 3, 4, 5 over 3. So if I make this line, that's at least hitting data, isn't it? So I would definitely say it's the pink more than the purple. And so I don't want you to get too hung up on this because I'm going to teach you how to do this on the calculator exactly, but you can get a good estimate. Okay, so what I would like you to do is I would like you to try 3 and 6. 2, 3, and 6. Pause and do 2, 3, and 6. Okay, so for sure on 2, I know it is not C and I know it is not D because those are negative slopes. And when I look at that thing, that is not negative. To me, my best guess it's A because 1/2 is going to be a flat line. Okay, so if I go up to 3, 1, 2, 3, and then I count up 2 over 1 or down 2, back 1, down 2, back 1, down 2, back 1. If you notice, I keep landing in all of these dots. So I really think it's going to be A. Now you can graph the other one just so you can see it if you would like. Goes through at 3 and you're going up 1 over 2 right away. I can tell that that's too flat. Okay, so the next one, same thing. I know this thing is going uphill, so I know it's not these negative ones. I also know that it's flat. So I don't think it's A. I think it's C. So you start at 0 and you're going up 1 over 4 or down 1 back 4. To me, that's right in the middle of all those dots. If I do the other one, start at 0, up 1, 2, 3, 4 over 1. That thing is way too steep. So I can just get this one by just using common sense. All right, the last one. Now this one's a little harder. So this one, it might be better to sketch a graph and get your y equals mx plus b. So, and we're gonna learn more on how to do that, but it looks like it goes through at about 1, 2, 3, 4-ish. B is a negative 4-ish, okay? And it looks like if I count the slope up 2 over, up 1, 2, 3 over 2. Up 1, 2, 3 over 2. Up-ish. Up 3 over 2. Okay, so if I look at this first one and I solve it, I would minus the 2x, so I'd get 3y equals negative 2x minus 12. Right away, I know this is wrong because even if I divide, I'm going to get a negative slope. I know it's not A because it can't have a negative slope. Okay, so then I'm going to go to B. I'm going to minus 3x, and I get 2y equals a negative 3x minus 8. Divide by 2, divide by 2, divide by 2. Same thing just happened. That thing is not a negative slope, so it's not B. Okay, so then I'm going to go to C, and I'm going to minus 2x, and divide by a negative 3. Y equals 2/3 x minus 4. Okay, that seems like that's close. I got the minus 4, right? But 2/3 would be up 1, 2 over 1, 2, 3. Up 1, 2 over, to me, that seems like it's not quite with the data. So then I'm going to go to D. So I'm going to minus 3x. And I get negative 2y equals a minus 3x plus 8. Divide by a negative 2. And I get y equals 3/2 x minus 4, which is what I got over here, 3/2 x minus 4. So the answer is D, and I did that just by estimating. All right, so we are not going to, there's a way on your calculator to do linear regression, and it will find the lines for you. But I just don't feel like that's going to be easy for you to do. So I'm going to teach you how to do this just on graph paper. So I gave you graph paper. No, maybe, did I get a new thing? No, go away. I used to be able to get graph paper. Oh, here. I just want to add graph paper. Oh, there we go. Stickies. I was like, where is this thing at? That is not. Oh, hell. Okay, let's try this again. Now that I know what I'm doing, grid. I'm just going to ignore that other one. And then paper, I want more. Okay. Okay. So we're going to do number 4. We're not going to worry about this guy since I put this graph paper on top of it. Okay. And we're talking positives. And so I'm just going to make my graph down in this corner. And I'm going to make year 0 be 1980. So this is year 0, 1, 2, 3, 4. So this would be 1984, 5, 6, 7, 8. So 1988. So this would be 4, 8, 12, 14, 16, 17, 18. Okay, so I'm just changing these to 0, 4, 8, 12, 14, 18, just so you can see, because then we can make an equation easier. These numbers are really between 400 and 382. So I'm just going to make this first one be like, we'll say 380. And then we'll make this be, because it's only going to 420. So I'm going to say 85, 90, 95, 400, 10, 20. We probably should, okay, we'll just go 390, 400, 410, 420. And then we'll say like 430, because there's a 432, 440. Okay, so I'm going to use these. I'm just going to estimate it. Okay, so I made a graph and I'm going to estimate these things. So in 1980, it was 422. So about right there. In 1984, it was 432. So 1984 was 432. In 1988, it was 404. In 1992, it was 420, so we're back up here again. In 1994, it was 395. Okay, and in 1998, it was 392. So it's not a whole lot, but it kind of is going downhill. So to the best of your abilities, this isn't a right or wrong question. I would like you to take, and I would like you to draw a line, and I'm going to like even kind of... Okay, and if I take this line and I move it, okay, I would say this is too low, this is too high, somewhere about in here, right? And so now what I'm going to do is I'm going to find these 2 points. At year 0, it's about at 440. This is an estimate anyway, okay? And then I'm going to follow the line, and right here, there's another good point. 1, 2, 3, 4, 5, 6, 7. In year 7, it's 380. That would be 420. Right? Okay, so if I find my slope, 440 minus 420, divided by 7 minus 0. Whoa, 0 minus 7. So my answer is 20 divided by -7. So about -27ths. Okay, and I know my y-intercept because that's on the axis. So isn't my equation about y equals -27 x plus 440? Now you're like, but how do I know? What if I got a different answer than you? That's totally fine. Okay, you're going to get something close to that. Okay, estimate the time for the 220 Olympics, which would be 40 years. So I'm going to take, and I'm going to put 40 into that equation. So -27 times 40 plus 440. I get my calculator. Okay. Times 40 and plus 440. And my answer that I got was 325.7. Now, I am looking at the answer key, and the answer key was 338.96. This is an estimate. There's no right or wrong answer to this. I mean, there's wrong answers. I lied. Like if you said an answer of 700, that doesn't even make sense in the data, right? If you look at the graph, that doesn't even make sense. Okay, so what you're doing with this is you're just graphing it and you're estimating the line. Okay, so I am going to just delete all of this writing on here, and we're going to do the BMI one next. Okay. I don't have to try to figure out how to put another graph on there. Okay, so the data in the table at the left gives the weight in pounds and the BMI in body mass for 6 people of the same height. Okay, so if I look at this, my X is like 150, 155. So this is my weight, right? Okay, and so I'm going to go ahead and start. This beginning is going to be 150, right? And then 155, 160, 165, 170, 175, 180, okay? And then if I go up the side, these are between like 20, I'm going to make this bottom be 20, and then I'm going to make this be 20.5 and 21, and 21.5 and 22, and 22.5 and 23, and 23.5, and so on. Okay, so I just was trying to stretch that out a little. So if I do the weights at 150, I'm at 20.3. At 155, I'm at 21. At 160, I'm at 7. Okay, at 165, I'm at 22.4. Okay, at 170, I'm at 23.1, so a little jump there, but it's still definitely following a pattern. And at 175, I'm at 23.7. So definitely follows a pattern. Like, oh, that was bumpy there. Make it straight. Okay, so I can use this point because it goes through all of them. So that's 20.3, right? So I know I have a point at 150, 20.3, and then if I follow these, it really looks like it's hitting this point really well, which is 170, 23.1. Okay, so you're going to find the slope, so 23.1 minus 20.3 over 170 minus 150. So I got to take out my handy dandy calculator here because I can't do this. 23.1 minus 20.3 is 2.8 over 20. Now this is a story problem, so I'm okay if you put this as a decimal. And I got about 0.14, okay? So now I'm going to put that 0.14 back in with one of these and find the y-intercept. So I'm going to do y equals m x plus b. So 0.14 times 150 is 21. And then I'm going to minus 21. And I get a negative 0.7. So my equation is 0.14x minus 0.7. All right, so there's the equation. So now the question says, Sam has the same height as the people in this group. If he has a BMI is Y, right? BMI of Y is 25, estimate his weight. So if he has a BMI of 25, which is his Y value, I'm going to put 25 in for the Y. So I'm going to take 25 plus 0.7. So I get 25.7 equals 0.14x. And then I'm going to divide by 0.14. And so I got 183.57. So the answer to this is 183.6, we'll say. Okay, the book got 180.6. 4. So we did not get exactly the same answer, but we got a good estimate. This is just about estimates. Okay, on the next one, this is a tad bit easier because if you look to the left, the graph is already made. So all you have to do, find the line of best fit. So you're going to take your pencil. You may mess around with it. I might want to take that and move it down a little. You think? Maybe up a little. That's close. It's going through, right? There's no wrong answer as long as it's kind of going through the points. So it hits right there at 90, 4, right? And if I follow it, I would say it hits right there at 100, because if I do that, 5.5. So if I do 5.5 minus 4 over 100 minus 90, basically it's losing 1.5 in 10 years. So if because this is the real world, so you can have decimals on this, 1.5 divided by 10 is 0.15, okay? So that's my M. So now I'm going to put that in with one of these, right? And I'm going to say, oh, they put these as 0. You know what? I hate how they do this. I honestly would change this to 0, 4, 8, 12, 16, 20. How many years it's been. It wouldn't change anything here. This would be a 0 and this would be a 10. And so when you minus 0, 10 minus 0, you would still get 10. So this is still the same answer. But it will help us better, I think, do this because you don't really want to find what it was, the annual tuition in the year 1900, because there probably wasn't even that college. So I'm going to do y equals mx plus b. I know it's 4 is my intercept. So I'm going to say y equals 0.15x plus, 4. Okay, I'm going to go ahead and stop this.